Hello everybody, Greg is here. Today I want to tell you a little bit about this publication in Science, about the first stable compound with beryllium-beryllium bond. So I will try to explain why this publication is interesting besides the beautiful picture. And let's start with a little history. The first organometallic compound which was synthesized and identified was this one. It's so-called Zeiss salt, and this is the guy Zeiss who discovered it in 1831. And he didn't only discover it, he was also able to understand that there is an actual connection between metal and an organic molecule, which is in this case ethylene. Of course, he didn't understand the 3D molecular structure. It was discovered much later, but nevertheless it was the beginning of organometallic chemistry. However, the real start of the modern organometallic chemistry is considered the discovery of sandwich complexes, the most famous of which is ferrocene. So this is the correct structure of ferrocene. In this molecule, an iron atom is located between the two cyclopentadienyl ligands, and it really looks like a sandwich. That's why the sandwich complex. The structure was discovered and understood by those two gentlemen, Wilkinson and Fisher, independently, and in 1973 they received a Nobel Prize for chemistry. This molecule, however, was discovered much before that by Poisson and Keeley, but they didn't have the tools to understand this structure, so they considered it to be something else. This cyclopentadienyl ligand is very special. It has a negative charge, and it also has those two double bonds. Of course, it's a formal representation. Actually, those electrons here are delocalized. This is an aromatic molecule, and it's like a benzene where you have a constant current in the ring. Something like that happens also here. So basically all those atoms here are equivalent, and all of them connect to the metal atom in this ferrocene complex. Now a few words about compounds with metal-metal bonds. It's a separate topic of organometallic chemistry. Well, you can see molecules with the metal-metal bonds as a small model of a bulk metal. Some of the metals, like those shown here, form bonds between them relatively easily. And by the way, you can check a video on my channel about some interesting chemistry of those type of compounds. But other metals do not really like forming such metal-metal bonds, and they need to be forced to do so. And that's probably how all this field started getting attention, because if the nature tries to prevent you from doing something, that encourages you to do it more. I was involved a little bit in such a project myself. For example, there were no known compounds with mercury-mercury covalent sigma bond. The group I was working in was able to synthesize such a molecule with organosilicon ligands. With mercury, it's very interesting actually, because mercury metal is liquid. Mercury atoms do not need to make bonds in the metallic state, but in this case we were able to stabilize such a compound by making those long chains on the silicon. You can think of it as a grip over mercury. So when this radical forms, those chains hold it and don't let it fall away from the molecule. And then two such molecules meet and the bond between the two mercury atom forms. That's at least our theory. Another interesting molecule which was synthesized with two metals and attracted much attention was a molecule with bond between two zinc atoms. And you can see here we have a cyclopentadienyl ligand here, but instead of one iron or other metal atom, we have two of them here. Again, likely the cyclopentadienyl, because it holds the atom so strongly with 5 carbon atoms, it stabilizes the molecule with one atom, and then two of such molecules dimerize. At least that's a possibility. So something like that was done also with beryllium. And the funny thing is that they really followed the same pattern as the paper about the zinc, although it's of course from different groups. So even the name, decamethyl dizincosan, a stable compound of zinc 1 with a zinc-zinc bond, and exactly the same name, same pattern of the name, diberyllosan, a stable compound of beryllium 1 with a beryllium-beryllium bond. And similar picture. Because why to make up things if you already have the template, right? I know that many of you will ask me, but okay, first time ever interaction between two beryllium atoms, so what? Look at the ferrocene. This sandwich complex, when it was synthesized, no one really knew how it will be useful. However, you can check even this channel. I had a video about ferrocenyl block copolymers. And so many molecules of these types, for example, with titanium or zirconium, became very useful commercial catalysts for polymerization of plastic using those compounds. Of course, when the people discovered this molecule, they didn't know it will be as useful within only 50 years. So same thing is here. You never know. So I hope you liked it. Thanks a lot for your attention. Please subscribe to this channel, share the video, like it, and support Ukraine.